Hello everyone, it's Jude Kennedy here, ATCL, and today I'm going to be going through a couple of examples of completing the square, which is one of the first components of AS Maths and also in, I dropped my Sharpie, also in GCSE further maths. Now this topic can be quite awkward and sometimes quite confusing, especially when we get into harder examples, but it's very useful for sketching curves and solving quadratic inequalities. So I'm going to be going through a couple of examples of how to complete the square. Then I'll be moving on to max and min points, and then I'll be drawing some graphs. That is the aim. I'll see how much I can get done, and I hope that this helps with completing the square. Hopefully I'll get this out as soon as possible. So yes, this is for AS Maths and also for GCSE further maths. So I was halfway through making this video and I actually decided to put this back at the start. Completing the square. Completing the square. The reason, why you do all this stuff. Now this is the confusing part of completing the square. Say you have x squared plus 2x. Let me see, minus 1 equals 0. I'm pretty sure this factorizes. Let me just check on my calculator. These calculators are great, by the way. 1, 2, minus 1. Yeah, 1 plus root 2 and 1, or minus 1 plus root 2 minus 1 minus root 2. So to complete the square, the thing you're doing is you're focusing on this bit here, and then this bit is the extra bit. So whenever your x and then you half this term plus 1 and square it, what this is equal to x squared plus x plus 1, because 1 squared, that's whenever you would actually multiply out the bracket, so x times x plus x times 1 plus x times 1 plus 1 times 1, and so you get x squared plus 2x plus 1. Now in this quadratic, so say that is this bit here that we just put in here, and then we also have minus 1 here. As you see, this is not the same as that because we factorized out this, so that's why we then take away 1 from this here because there's an extra 1. So that extra 1 is then taken out of the bracket, or say it was plus 3, it would be a take out a 9, which means that the equation simplifies back to x squared plus 2x plus 1 minus 1 is 0, minus 1 is 0. So then that's why we do x plus 1 squared minus 1 equals 0, because whenever you expand that out, you will get x squared plus 2x plus 1 minus 1 equals 0, which, as we saw, simplifies back to give us that. That is why you have to take out the thing, and then that helps us to be able to then equals 2, and then that helps us to solve it like that. That is why you have to do all the stuff with this to get that, and that's why you have to take out the thing. I just wanted to clarify that because it can be quite confusing, because sometimes a teacher will use the method where it's x squared plus 2x, and then you have to add half the square of that term, which would be then it's the half of b squared, so you add half of b squared, or half of b squared I should say, so adding half of b squared would be 1 squared, and then you take away b squared, and then you take out this and you factorize that to give this bracket. That is quite a complicated method, I find, which is why that is how I explain it. I hope that makes sense. So let's get into the first example. Today I am using Edexcel, AS and A-level modular maths C1, however I do CA. This book just has some good examples which I was able to find at my house of quadratic inequalities. So let me just open to the page of questions, and I'm working from 2D. If you have the book, it's exercise 2D. So the first question is x squared plus 6x plus 1 equals 0. We have to solve this by completing the square, and also if it doesn't say by completing the square, it might say give your answer in third form or in form a plus b root c, for example. Or it also might say give your answer as an exact value. So those are the two methods. If it was to two decimal places, you could complete the square. However, that's when you use the formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. That's to two decimal places. But yes, we are going to be completing the square. So say the question said give your answer in third form. So I would go x squared. I shouldn't have turned that. That was all in line. Anyway, x squared plus 6x plus 1 equals 0. So the first step of completing the square is making your squared bracket. So what you do is you ignore the c term, like this, just ignore it, and you look at the two x terms, one is x squared and one is x, and you're going to half the coefficient of x to get x plus 3, so that's half of that. That's squared. However, we're not considering this part of it. All we want is a squared term of this section here, which is just the x squared plus 6x. So that means we have to take out a 3, but we actually have to take out a 3 squared from this. We're taking out 9, which means we've got this section, and then we've got this section, which is, if you multiply it out, you'll get x squared plus 3x, which gives you x squared plus 6x, and then we're taking out a 9 because that's not what we want from that, and then we also have to add the extra 1, and that is equal to 0. So x plus 3 all squared equals 9. Minus 9 plus 1 is minus 8, so it equals 8. X plus 3, so this is now just solving it. X plus 3, we're square rooting this side, and that means we have to square root this side too. When you square root, you get a plus and a minus answer. Plus and minus, root 8, and from thirds we know that is plus or minus 2 root 2. X equals, bring the minus 3 over, and then plus or minus 2 root 2. Now this is in third form, so if say it was find the value of a, b, and c, that would be a equals minus 3, b equals 2, and c, sorry, that should be up here, this should be a plus or minus b root c, because you will get your two answers. But yes, b equals plus or minus 2, and c equals 2. There we go. Simple as that. So that is how you complete the square, but this is quite an easy example because 1, this is an even number and divided nicely by 2, and 2, there's no coefficient of x. So I have this calculator here just in case. This is the calculator I've been using for GCSE further maths, and now also what I'm doing in A-level maths, just using the same calculator. Okay, so our next question is a little bit harder. It is, let me realign everything here. It is 4x squared minus x equals 8. And we want to give it in our answer in third form. So we rearrange the equation to get a quadratic. 4x squared minus x plus 8, bring it over to minus 8, equals 0. And what I'm going to do is I'm going to divide through by 4. So technically what you could do is just divide the whole thing by 4. However, when completing the square, sometimes it's more useful to do this method. So we're taking a 4 out of the equation, so it's x squared minus x over 4 minus 2 equals 0. I'm using square brackets just because it's the whole thing. I'm going to be putting normal brackets inside there anyway. This will come in very handy when we're finding maximum and minimum points, which is why I do it in this method. So 4 upon, and then it's your x, then we've got minus, and then this is x over 4 is the same as 1 over 4x. I just like writing it in that form. Anyway, so we're going to half 1 over 4, and half of 1 over 4 is 1 over 8. So minus 1 over 8, that's squared. Then we have to take out this squared, so because remember when you multiplied it's x squared minus 1 over 8 minus 1 over 8, and when you add 1 over 8 and 1 over 8, you get 2 over 8, which is 1 over 4. And then we also have to take out minus 1 over 8 times 1 over 8, which is 1 over 64, and take away 2. And that is equal to 0. 4, and then x minus 1/8 all squared. And then, let me see, I've done this question before, so I know how to do it. 1 over 64 minus 2 equals minus 129 over 64, and that is equal to 0. At this point, you can work out your maximum and minimum terms by multiplying 3 by 4, but we're not doing that, we're just completing the square, so I can divide 3 by 4 now. X minus 1/8 all squared, and then I'm just going to bring this straight over, and you get 129 over 64. Then square root both sides. So we're square rooting this side, which means you have to square root this side. You get plus or minus, because when you square root, you always get a positive or negative term. 129 over 64 square root is 8. Now we have x, and we are adding on an 8th to this side, so we have to add on an 8th to this side, plus or minus root 129 over 8, and that is its simplest form. You can obviously put this all over the same thing, so this is the same as minus 1 plus or minus root 129 over 8. So that is that form, and obviously you get your two answers because you have a plus and a minus term. And now the last, just completing the square question I'm going to do. I think I could probably fit it in. Yeah, I can probably fit it in down here. I'll do it in a different colour just to separate it out. Let's pick light blue this time rather than sea green. So our question is x squared plus 6x plus 1. No, that was our first question. Why am I so stupid? Let's just take a new page. It's probably easier. Right, that. Oh, and you've moved. Hello. Let's go back here. Okay. Yes. Our new question is this one. Minus 2x squared minus 6x plus 15 equals 0. Let me just make sure that question's correct. Minus 2 minus 6 plus 15. So we have a minus x squared term, so if we were drawing a curve, it would look like this. You know, it's going to be an upside down curve because it's negative. What we're going to do is we're going to take out a minus 2, and we get x squared. We get minus and a minus, which means a plus. We're going to put 2, or 6 over 2 is 3x, and then minus and a plus is a minus 15 over 2 equals 0. Now I'm doing this for the same method for whenever you go on to find maximum and minimum points next. This is the easiest method of doing this, I find. So yes, this is then minus 2, and then we're going to half this value, so x plus 3 over 2 all squared. You have your x squared, you got 3 over 2 plus 3 over 2. Then you don't want your 9 over 4, because that's the squared. It's 9 over 4, and then we're taking away the 15 over 2. And that's equal to 0. Now 9 over 4 minus 15 over 2 I worked out to be minus 39 over 4. So minus 2 x plus 3 over 2 squared minus 39 over 4 is equal to 0. Now at this point you work out your maximum and minimum values, maximum or minimum values. So I'm now going to divide by 2. X plus 3 over 2 all squared equals 39 over 4. Now we're going to square root both sides. 3 over 2. So we're square rooting that. That means you have to square root this side. And you get a positive and negative term, 39. And square root 4 is plus or minus 2. Now what we do is bring over the 3/4 and it's, or 3/2, and it's minus 3 plus or minus root 39, and that's all over 2. The denominator is the same. So that is completing the square, just for the sake of solving quadratic. You can obviously do this by using the quadratic formula. However, sometimes it's just, I like completing, sorry, I moved Joel again. I like completing the square when I know you can factorize it. Sometimes it's quicker, or sometimes whatever, in further math using complex numbers, sometimes it's just easier to complete the square. So, next I will do finding maximum and minimum points of quadratics. Now it is time for sketching quadratic graphs. Sketching quadratic graphs. This can be done in a couple of ways. You can get your equation, so let's use x squared plus 2x minus 1 equals 0. You can factorize that. Actually, you can't factorize that because your answers are minus 1 plus or minus root 2, so you can't actually factorize it, but if you could factorize it, draw your graph, your intercept is minus 1, and then you just draw the curve through all the points. However, you can sketch quadratic graphs by completing the square. I'm just going to put a square there, by completing the square. So, to complete the square, we go x plus half of that is 1 all squared. Take out that squared, minus 1 equals 0. X plus 1 all squared minus 2 equals 0. Now, obviously I know that that's true, but at this point, I'm able to find the turning point of the graph. So, if this was equal, instead of equal to 0, this could be equal to y. So if we take that out, y equals this. Y will be at its lowest point, minimum. Obviously, because this is a normal quadratic, the graph will look like this. We have a minimum point there. Y will be at its minimum whenever this is equal to 0. The bracket is equal to 0. Why, you ask? Because if we have 1 in the bracket, 1 squared is 1. If we have minus 1 in the bracket, minus 1 squared is 1. So whenever, I'm just going to bracket squared equals 0. 0 is the smallest you can get anything squared to be. Obviously, because negative numbers squared become positive. So whenever this bracket is 0, this bracket squared is 0, so y of its minimum, so minimum y, min y, or min y, equals, so this is 0, so it's just minus 2. Because that is 0, y equals minus 2. And whenever x equals, so we want this bracket to equal 0, plus 1, and then x must obviously be minus 1 for that bracket to be 0. We know that the turning point, so the small, like in the graph here, this point here, so we have the y direction, then we have the x direction. This is the lowest y value in the whole graph, and then obviously it will be at the x value across. So the turning point equals minus 2 is the y value, and minus 1 is the x value, so our coordinate is minus 1, minus 2. So we'll continue with let's bring this down here, and we're going to finish completing the square. That was an awful arrow. Anyway, yes, let's finish completing the square. X plus 1 all squared equals 2. X plus 1 equals plus or minus root 2. X equals minus 1 plus or minus root 2. We have now successfully completed the square. We have our two x values. We also have our y-intercept, where our curve will cross the y-axis, which is found by, so this is again equal to y. When x is 0, so whenever on your graph, here's the x and here's the y. Whenever x is 0, which is this bit in the middle. Y is equal to minus 1 in this case, so that is where it will cross. So we now have our x values, or our roots of the equation, which is minus 1 plus or minus root 2. We also have our turning point, which is TP, which is equal to minus 1 minus 2. And we also have our, I call it C because, you know, y equals mx plus c, or c equals minus 1. Now we have to draw the graph. I'm going to quickly grab a black pen and sketch some axes. So we have x and we have y. Now, what I like to do is work out my x values. So this here, we have 1 plus or minus 1 plus or minus root 2. So minus 1 plus root 2 equals 0.4, so it's going to be on the positive side of the x-axis, and then minus 1 minus root 2 is minus 1 minus root 2, which is equal to minus 2.4. So we kind of have our values, it's 0.4 and minus 2.4. So say we put that here, that is 0.4 approximately, or you can, in an exam, you'll write that as minus 1 plus root 2, and then here just a bit further on it's minus 1 minus root 2. Our C, where it crosses the axes, is minus 1. That's there, minus 1. Now these are all approximate values. I'm going to put an x through them. And then our turning point is minus 1, so say that's here, minus 1, and minus 2, which is here, and we put that cross there. So now we kind of have points where our curve is going to go through, and you want to just have a smooth curve going through all the points. So I'm going to give it a go now. That wasn't great, but it goes through all the points. It should be a nice smooth curve, but that's sometimes always hard to draw. So that will get you the marks, but it should maybe more be, I'll try in a different colours. I'll try in blue to draw a better curve. Should be more like that. But anything really that goes through all the points will get you the marks. Now, however, if we go back to our previous questions and we do this, if we go back to one where we have a minus 2 outside, to be able to get our graph, we need to find our turning points, or turning point. And that is our, whenever it's equal to y, is this value. But this is still multiplied by minus 2. Remember, this is why I took this out. So our turning point, instead of a minimum value of y, because our curve is like this, because it's a minus x squared, if we look back, it is minus 2x squared minus 6. We'll have this here, which is our maximum, equals maximum y value, and then we'll have whenever x is equal to. So max y equals, it's minus 9/4, or minus 39/4 multiplied by minus 2. So if we were then to take this, we have minus 39/4 multiplied by minus 2, 39/2. And we get this whenever x equals, so remember the bracket has to equal 0. If we multiply minus 2 in, we get minus 2x plus minus 2 upon that. But then obviously you just divide it back out to get what x equals. So x equals x plus 3/4. Take away 3/4 to get x. X equals minus, or not quarters, 3/2, sorry. X equals minus 3/2 to make that bracket 0. If, just to clarify, it would be minus 2x plus, and then I'm going to work out minus, or 3/2 times minus 2, and you get minus 3. 0, minus 2x equals minus 3, and then x equals minus 3 over 2. Positive. Bring that over, it's positive. And then x is minus 3 over 2. So that's just to clarify, but it's the same thing. Then we draw our graph. Remember, we've already worked out our x values. So here's the grid. There's the x. And here's the y. Then we know that our maximum y value is 39 over 2, which is just under 20. And we know that x is equal to minus 3 over 2, so that's 1.5. That's about here. That's our top of our curve. And then we have our answers, minus 3 plus or minus root 39 over 2, minus 3 plus root 39. That's all divided by 2. So I'm just going to put brackets around it, all divided by 2. Yes, that equals 1.6. So that's minus 3 plus root 39 over 2. And then if it was minus root 39, I'm just going to change that to the calculator. It was minus 3, wasn't it? Minus 3 minus root 39 over 2 equals minus 4.6, which is definitely further this way than that. So here we go, where this is minus 3 minus root 39 over 2. And then we also have our y-intercept, which is, from our original equation, 15. That's about 15 there. And now what we do is we try to draw a smooth line or curve through all these points. I did not draw this very well. This should be a lot higher up, but it's okay. That's an exam error that I make quite a lot. So we come up and we join the points smoothly and get a curve. And that is how you do that, pretty much. That's how you draw the curve. And yeah, that is sketching graphs by completing the square, which is quite complicated. It is quite confusing, however, you can do it. So you can complete the square. You can complete the square. You can sketch quadratics by completing the square. The next step is quadratic inequalities. They are the next step up from all this. For example, here's one, here's our graph, and I want to find whenever, so just pretend this graph is f is a function of x, which is equal to y. I want to find whenever the function of x is less than or equal to 0, and whenever this is less than or equal to 0, so y is less than, this is also y, remember, y is less than or equal to 0, it's inside here. I will explain more on that next time, if I can make another video. So, thank you. Thank you for watching, and I'll see you on the next video. Don't forget to, here's me attempting. Don't forget to give a like, and subscribe if you haven't already. And I'll see you on the next video. Bye.